Ferris wheels are fun, until your professor makes one show up on your midterm. Here's the setup from the last video. We've got a Ferris wheel with a radius of 20 meters, spinning counterclockwise at 1 radian per second, and slowing down with an angular acceleration of negative 0.1 rad per second squared. The goal is to find the velocity and acceleration of 3 passengers sitting 90 degrees apart, written in x and y components. First, let's make the picture. We draw the wheel, place the x-axis at the center, and number the passengers. Passenger 1 is at the top, passenger 2 on the left, passenger 3 at the bottom. To start, we sketch the force vectors, weight straight down, and velocity vectors tangent to the circle at each position. For velocity, the polar form has a radial term and a tangential term. Since the radius does not change, the radial term cancels. What remains is radius times angular speed, always tangent to the circle. And if you're wondering about the E symbols in the formulas, E sub r and E sub theta are just unit vectors pointing in the radial and tangential directions. Some books use different letters like U or V, but the meaning is the same. All 3 passengers have the same speed, but the direction depends on their position on the wheel. At the top, the velocity points left. On the left side, it points up, and at the bottom, it points right. This makes sense, since everyone is the same distance from the center and should be moving at the same speed. For acceleration, we again use radial and tangential components. The radial part always points inward toward the center, with magnitude equal to radius times angular speed squared. The tangential part points along the direction of motion, with magnitude equal to radius times angular acceleration. So the process is to sketch those 2 directions at each passenger, radial pointing to the center and tangential along the circle. Then substitute the values and translate them into x and y components. That gives the acceleration vectors for all 3 passengers. The overall strategy is to start in polar coordinates with radial and tangential components, then convert everything to x and y. Now here's the question. How would this change if the Ferris wheel suddenly drops from the center? Drop your answer below and like and follow for more dynamics breakdowns.